Forging cyber security experts. Secure Ninja.
Hey everyone, I'm Alicia Webb with SecureNinjaTV. Now, our free preview of SecureNinja's online Sensei series has generated such a positive reaction that we've decided to give away every single module from this Cyber Kung Fu course featuring Larry Greenblatt, Tom Updegrove, and me. If you like what you see and would like to experience a Secure Ninja training course in person at any of our training locations, we have some amazing time-sensitive specials for you. Just visit SecureNinja.com/specials for all of the do not miss deals. And now, here is your free module from Cyber Kung Fu for the Certified Ethical Hacker version 8. Enjoy.
Okay, welcome back to Module 8. And in Module 8, the whole idea is sniffing. So sniffing, in fact, I've got a little definition for sniffing. Could you want to read it?
Absolutely. Yeah. Sniffing a network. A packet sniffer is a type of program that monitors any bit of information entering or leaving a network. It is a type of plug-and-play wiretap device attached to a computer that eavesdrops on network traffic.
And when we're talking about network traffic, we're talking about the packets themselves. So we have a saying in sniffing that the packet never lies. So if you want to know what's going on at the packet level, you pull up a sniffer. So we're going to use two different sniffers. Even when we pulled out Kane is a sniffer as well. They all work pretty much the same. My three favorites are Colosoft's Capsa, Wireshark, and Kane Enable. So here I actually have Colosoft Capsa installed on my host machine because I use this all the time actually for network performance and as well just watching what's going on. So you had a question earlier about, hey, how do you know if you've been hacked or something weird's going on? And the best way to tell that is really to see what's happening on the wire, what's really going in and out of your machine.
Right.
So, and I think you're going to be pretty amazed, surprised at how crazy it is. So we're going to bring up Capsa. So my super Windows interface, right? Caps. Here, I actually have the full version. The people at Capsa are really nice to actually give me an enterprise level of it. And
cool.
It is cool. Okay? And there's a lot of things I can do. I can do a full analysis. I can look at traffic and see who the top talkers are, who's taking all the bandwidth. I can see who's downloading what. It's pretty good for actually monitoring the actual network. We're going to do a full analysis first. So here I got to pick the adapter, which I'm on my Wi-Fi adapter, and I want to start. And this thing will go to town right away. I don't need this. I have a nice little online resource of how to use the tool.
Yeah, this is a good interface. Looks good.
But we'll kind of drop that. Okay, so there's not a whole lot of, because we don't have it a lot, but I am actually on, I'm on the network that we have here at this point. And the thing about it, the first thing I look at is I go over to this IP Explorer, okay, and I drop that down. And basically it's going to tell me down here who I'm talking to in the United States. Now I haven't done anything yet, but yet you can see that I've got some chitter chattering going on already. And I can see the 75, 75, 75, 75. That is, I know that's Comcast. So that the internet provider here has to be Comcast. That's one of their DNS servers. And one of the ways I find this out is I click on it, and then I come down here and I do an address resolve. And I hit that, and it'll kind of run through a resolution of as to who that is. Okay? And sure enough, there it is. You know, and I'm going to add that in to my my name table, okay? And you'll see that actually as that happens. I didn't do that right. Okay. Add the name table. Oh, create a profile. So we'll call it Prime. And sure enough, then you'll see instead of us looking now at an IP address, okay, we're looking at a vanity name for it, you know, so we can identify that. Okay. And now we've only been on the network a short bit here. You can see that I've got a host of servers that I'm talking to, but who the heck am I talking to? I haven't done anything yet. Yeah?
Right.
And if I do something really just simple, like say pull up Google and go to Google News, you know. Yeah, in fact, I made a mistake there, but I pulled that up. You're going to see that as that's kind of pulling itself up, the number of boxes that I've just connected to even gets crazier. And you can see now, why am I talking to somebody in United Kingdom? Okay. Well, it just so happens this is my work machine, and I run a managed service service out of this, which actually connects to a series of computers. It ties into a company called Citrix, and they run a series of servers that are kind of global. And what happens, it gets really chatty, and I see in a short time myself hitting all of these different boxes. But if I want to know who 173 is, I'm going to resolve the address. Okay? Doesn't take long, really, to resolve it. 100 net. Who is that?
I don't know.
And so, in a sense, sometimes you got to go a little deeper, and you got to really kind of pull it apart, resolve the address. So if you really want to know what's going on, you've got to actually now track down each one of these connections and find out who you're talking to.
So, and this is a prevention type thing in case a hacker's talking to you? And
not necessarily, but I've seen it talking to somebody like botnet.cc. You know, that's not a good thing.
Right.
You know? Certainly not a good thing. So it could be. The trick is I have to identify each and every server that I'm talking to, and I should have a reason why I'm talking to it.
And then if you find something that you're not comfortable with, would you cut off the connection?
Then I can now set up some rules, say do not talk to this particular thing. And it happens. I see machines that are kind of been pwned, and what we'll do is we'll just set up a blacklist and say not talking here. A lot of times I put in these firewalls that the firewall will make access lists to say only talk to servers in the United States or don't talk to servers in Turkey. So you can actually set up a country type access list so that you only can talk to certain people. Now the services that I run, they'll do well enough just talking to servers in the United States. Another really kind of cool feature here is when I go over to the matrix and I pull the matrix up, it will pull up an entire, so when I go up and I hit internet addresses, let me go the whole, so internet addresses. Now for just getting on the internet a few minutes ago, look at the conversations going on there.
Yeah.
You know? That's insane.
That's quite a bit.
Right. You can see that actually my name tables are kind of working out. So I've kind of built name tables prior to this.
Oh, okay.
In some cases, so I can click on that one and I can actually resolve the address. It's node and insecure nodes.
Why is it that you're talking to so many just from doing a simple Google search?
Because that's the state of the internet today.
Yeah.
And part of it has to do with the type of services that I run on this, because this is my work laptop, and part is the way that the cloud works now. So that if I'm say I have servers running it in Amazon's cloud. Well, I may have servers running on the East Coast, they may have servers running on the West Coast, they may have servers running in South America. All depends on how that's set up. Right. So that that's really the redundancy of the cloud. Some other little things about a program like this, so to understand a little bit more about what goes on. Now we're looking at each packet here that's going in and out. So if I want to know a little bit more about it. But basically what this is going to tell me is a little bit about the kind of sequence that is actually, it's my buffer. So in here, it will actually capture, not only is it telling me real time what's going on, but it allows me to actually capture the traffic of what's going on. I've kind of set the buffer kind of small. So I want to make my buffer a little bigger. So my packet buffer, say I've only made it 16 megs, so I can increase that, make that much bigger. Say 115 megs. And circular, so it's going to load in 115 megs and then start dropping the oldest packets. I could set it up so that it'd do 100, save that, and then do another 100 more. So a lot of times you want to do a cumulative. So you can't sit here and watch it, but what you could do is actually record. The cool thing about this program is it also allows you to set alarms. So an alarm would be kind of a filter that when this particular IP or this particular range of IPs are actually we're connected to, it will then save that information. So if I'm not sure about a particular connection, I can kind of capture that information and go back and look at it on the packet level. There's some interesting things that can happen on the packet level, this program is really pretty good in terms of seeing what's happening on the packet level. So maybe I'll get an older packet. Yeah, so what's happening here is it's actually talking to me about the actual data flow in the handshake. So we talked earlier about, and you'll find in the lecture that there's what's called a three-way handshake. There's a SYN, a SYN-ACK, okay, and then either a reset, okay, or a fin when the conversation's over. Kind of like when we're on the phone, and I ring you, you go hello, and I go, oh, hi, Alicia, and you go, hey, hi, Tom. Okay? So we've kind of made that communication. But if the phone rang, and you went, you didn't answer.
Right.
I'm waiting for an affirmation. Or if you go, I go, hi, Alicia, you don't say anything. Or you say, hi, Tom, and I don't say anything back.
Right.
It's kind of weird because you're really not getting that whole handshake.
Right.
And people use that sometimes just to tell, like, if I wanted to know if you were home, I'm sure this has happened to you, I would call, you would answer, I go say anything, I hang up. Okay, and go, oh, I know she's home. So in a sense, we know that you're alive and well there, but you're not sure who it was that called.
Right.
You usually have your suspicions, don't you? What this will do is it will allow you to kind of drill down and look at the kinds of conversations that are going on. In here, there's really not much. There's just like, there's an act, but nothing else.
What kind of conversations can we find? What can we infer?
That's a good one. Actually, I'm going to, the ability to look deep into the packet is less in this program than in Wireshark. So Wireshark really is the quintessential packet examining tool there is. Everybody uses it. I don't care if you're in security or if you're in your network admin and you're looking for performance, Wireshark really is the tool to use. So we're going to roll right into Wireshark.
Cool.
Okay, so I'm going to basically shut this down, okay, but I'm still, don't want to save it. We get rid of all these. We don't need to what happens, we get these VMs running, they really kind of suck up a lot of juice. All right, so, so I'm going to pull up Wireshark. Now, Wireshark has a capability, again, of seeing everything that's happening live on the wire. Whether it's a wired network or a wireless network. I think we pulled that up, right? Ninja's looking good.
I know. He's ready to fight, always.
Come on, Wireshark.
Come on, Wireshark.
You notice how
Scared of
people
that
sit
ninja.
around and they talk to their computers?
Yeah. Sometimes they do, don't they?
There we go. We don't need that.
We see Wireshark at a lot of these trade shows we attend.
Oh, really? Yeah?
Yeah.
Yeah, I go out to the Shark Fest every year.
Oh, yeah?
Yeah, because you have that people who actually develop this program along with users. And I find every year I go out, I learn a little bit more about the program and you know, ways to utilize it. Now, if I were to use this program to just see what's going on, I'm going to hit interface, and then I'm going to pick the interface that I want to sniff on. It just so happens that I've got traffic running. This is probably my wireless interface here, because I got the most traffic on it, and I would start just kind of sniffing. So basically, it's just watching the whole conversation of what's going on between 192.16.2.50 and 52.
And what can you determine is going on from what we're looking at?
Well, right now, there's not much going on, but for instance, let's say, again, I pulled up my web browser and I decided to go out to the internet. So we know that this is HTTP, right? So if I just make a filter, go HTTP, this is the cool thing about and apply the filter. Basically what it'll do, it will fill out everything except anything that's going on to the web. So what you're going to see is these requests to Google to link up. And as we kind of look through here, we'll probably see the actual handshake between myself and Google. So starting here, okay, getting PKI. So basically what's happening is it's trying to, because Google runs on an encrypted level, so it's trying to address and understand the encrypted handshake that happens there. But what I wanted to show you with this is not so much what's going on live, is what's going on if I load in a file. So I'm going to stop this capture.
Okay.
Right? Now what I'm going to do is I'm going to open a file. I'm going to continue without saving. And I want to get, I have these are all dumps from customers. I guess customer here, they had a phone problem. They have a voice over internet system, and they were getting calls that were dropping out. So we used Wireshark to actually nail down really what the culprit was and why it was happening. So here, in CEH, in my V8, under my tools, I've got a Wireshark folder. Now what this is a dump of somebody has pop email. Okay? And in this case, I'm going to clear the filter. And what I want to look for in here is maybe something like password. I mean caps. So that's what I would do. I would go in, I'd hit find packet, then I put it in a string, and then I'm looking for anything like user. You know, what it will do, it'll kind of scan through the file, and it will actually, you know, find that.
So what exactly makes up packet? What information is contained in a packet?
Okay, it's a good question.
Thank you.
So there are all different protocols and types of packets, but basically a packet is a bit of information that'll have a certain size that is going to be shipped from one device to another. So basically the packet will have a frame header which will have the address of where it should be delivered. We'll also have information about where it came from. So that it could be identified by the receiving machine, and certainly it has to have information about where to send it back. So when you hear packet-based, packets is a type of delivery mechanism that has been developed far different from all previous communication, because all previous communication were in certain kind of waves. Like radio waves, or the way TV was delivered, you know. So it's kind of a stream of an analog wave. Packets, everything's pushed into one piece, and it's almost like blood corpuscles, you know, the way they'll flow. Except that every packet will have a source and destination to it, and as they arrive at certain points, the frame headers are going to be stripped off, and they're going to be rebuilt, and then delivered on to the next stop. Okay, but in a nutshell, it's an addressing scheme and a way of passing information back and forth in small bits. Okay. So you may have hundreds of packets that are delivered, and it may be delivered out of sequence, you know, just because they took different routes. So then, as they arrive, they have sequence numbers, and they have to be then reordered and put back in there. So you figure if the packets we were talking about were voice related, right? So that voice packet is going to be, they may arrive out of order, but yet they have to be put back into order if you're going to hear the voice stream correctly. And voice and video are even more important than data. You know, because data can arrive a little slower, before it's put back into order. But voice, you won't.
Yeah, I'm just thinking about all those
you know how it is. Sometimes
bits.
you get that kind of jitter, and that's because the packets are arriving late and out of sequence. And that's due to either there may be some issues on the local area network, and there may be some issues out in the internet. And then there are aspects of it where you have a quality of service that says, all right, voice and video, we want to give higher preference to than, say, the data stream. But sometimes the case is you want to give a higher preference to the email flow than you would to, say, somebody is downloading music, or, so it all depends on really what the requirements are. But that in a nutshell really is Wireshark and basically sniffing.
Right. Excellent.
What other questions might you have?
Well, I know that one thing you say is that packets never lie. What exactly does that mean?
It means that when you go in and you examine, even though somebody might spoof an IP address, when you look down in the packet, you can see that where it came from.
Oh, the real IP address.
Yeah, you can see. So you can determine really what the level of misdirection is.
Okay. So the truth is in the packet.
And it's even more cases sometimes, the truth is in the packet. Some cases you might be, why a lot of people use these tools is everybody says, well, why is my connection to the internet slow? So the person who wrote the application say, well, it's got to be the network, right? And the network engineer is going, no, it's the application, right? But when you look down at the packet level, you can tell really where the problem is. And it's usually some legacy equipment that isn't performing the way it should be.
Right. Excellent.
Good. So there you have it. Wireshark and Colosoft Capsa. Packet sniffing.
The truth is in the packet. Now we hope you've enjoyed this free module, but there's lots more. The Cyber Kung Fu course has 29 videos in all and will really help build you a solid understanding of the CEH version 8 curriculum. Don't forget, if you prefer to attend one of Secure Ninja's courses in person at any of our training locations, you really need to visit secureninja.com/specials for some amazing discounts and other deals. I'm Alicia Webb. Happy training.
Secure Ninja TV is brought to you by SecureNinja.com, a world leader in cybersecurity training and certification. Our master instructors will help build you into a highly skilled and marketable security professional. Secure Ninja, forging cybersecurity experts.